introduction. Thank you very much.
Thank you, sir.
Thank you for this opportunity, and very nice that able to see about more than 150, and it's going on.
Yes, sir.
Yeah. Thank you for giving me this opportunity to spend my time with the eminent professors who are here. The topic given to me is deep learning for malware detections. So just I want to give some brief idea about deep learning in the initial stage. As you know, you're aware of it, but however, for the completeness, I will spend some time in what is deep learning and how to design it. Then I will take you to that what is malware and what is network intrusion detection systems and what is the need of deep learning application in that. Then how we can design a deep learning application for malware detection. This is the objective of my presentation. And as we understand that deep learning is a subfield of machine learning, and it comes under artificial intelligence. And mainly, if you focus more on deep learning, we should understand that as that deep learning algorithms are inspired by biological structure and function. It looks like our function of our brains. Okay, so in a nutshell, we want to give some intelligence to the machine. And here we want to use our biological structure of our brain, how our first brain functions. The same way we want to imitate the system to learn from the data. Okay, so why we need to learn from the data? We want to make our systems more intelligent. To introduce all these things, we want to have some deep learning algorithms. Okay, so to understand this in very clear manner, we should know what is AI. AI is nothing but we want to introduce some intelligence to the machine. And if you say it's intelligence, we need to understand about what is intelligence. Okay, I can understand you can't talk to me. It's muted. That's fine. Okay. So
sir, yes, sir. Like participants can please raise your hands if you have to answer so that I can unmute you.
Oh. If possible, you can unmute all of them so that anyone can interact with me at any time. Will it be possible?
So like if you want, maybe I'll unmute everyone right now, but then like there were certain disturbances, that's why I've disabled, but that's okay, sir. I'll unmute for everyone.
Yeah, that's okay. At least we can have interaction.
Yeah, sure, sir. Yes, sir. Like the mic is enabled for everyone. They can unmute and talk now.
Yeah, fine. So what is intelligence according to you? Any one of you, please.
Self-thinking capability.
Yes, it's a thinking capability. And other than that, we should think in another way is we have to react to the particular environment. The human, we can say the human is having an intelligence in terms that according to the environment, according to the situation, he will react. Okay, that we can call that as intelligent. We can say we may introduce this intelligence into the system by explicitly programmed. Meaning is a washing machine or ATM machines. We can say these are programmed by the software engineer. And if you want to say, I want to use the washing machine. Okay, in that I want to have some about 10 cloths. So what should I do? I will throw all those things into that machine and pour the liquids and all the stuff. And I have to click the button, say like maybe a cotton. I have to click that button. Then according to that option, it will take that much of water, that much of liquid, and it will rotate that many times and drain it and then wash it again. So many how many times it should wash according to that program, it will do. So here we can say this is a explicitly programmed, meaning is the software engineer designed it. He already he understood what to do, and he did all this program, and that was available in that system. Okay, so meaning of this system here is in a washing machine, that particular program is already happened and it is there. According to that, it will do. But now what we are looking is when we go with this kind of AI, ML, and deep learning kind of concept, or generally it's in artificial intelligence, we want to incorporate intelligence to the machine so that the system will learn from the data and it will react to the scenario. But we don't want to give any explicitly programmed one. It should not say like it should not be a if then rules and all the other stuff. Rather than that, the system should learn itself. Meaning here is it should learn from the data and it will react to the particular environment appropriately. But always you have to understand that as there should be some human intelligence is required to support this machine so that this the machine will learn it better and it will react to that environment in a better way. This was Andrew NG gave this. So some examples for ML is we already have a rule. Okay, if we say the rule for pass in a student to pass in a particular exam is we can set say internal examination he should get about 40% and for external examination he should get 60%. All these things we already set and we are able to do that. That is a explicitly programmed one. Now for better understanding, what I'm saying is we should not say that to the system, but the system should predict who will pass and who will fail. How it should do is it should consist of a lot of data. The existing data should be given to the that system, say that these kind of students are passed, this student is failed, this student is passed. That information should be given to that system. But we are not setting the rule. Say like he should get 30% marks in external or 40%, whatever the mark you want. You are saying now you are not saying, but the system is learning itself by doing trial and error. If it's do, we can say it's a machine is learned from the data. We can call this as a machine learning algorithms. Right now we have a very good machine learning algorithms and it's working properly. Okay, but why we need a DL instead of ML? Can anyone give some clue? Why now everyone talks about DL?
The manual feature extraction process.
Okay. That's the only thing. Any other point? Okay, yes, machine learning is actually working better, very well for a variety of problems. It excels in many cases than even compared with the humans. It's working better for some cases, but for some cases it is not able to process well or it is not able to give us the better results. When we compare with the humans, humans are able to give the answer very properly, appropriately. The accuracy is very high, but the system is not able to do that as because of the data is unstructured in nature. Most of the data is unstructured in nature. Say, for example, the image kind of data or some other audio, video kind of data, the system is not able to perform well. Okay, it's because of, I can say in a nutshell, it's because of unstructured in nature. Feature extraction is the other parameter, but it's one of the underlying thing, but we are focusing more on the concept oriented thing here. The concept wise, it's us because of the unstructured data, its machine learning will not work very properly. Okay, so deep learning will come here and it will help us to excel better than ML. Tomorrow something may also come, but that's a different issue. But at least as of now we have DL. Why DL is required is we need a better performance in terms of good accuracy and good response time and all the other stuff. But achieving all these things is again always this is a bottleneck. That's a research. We have to ensure that how to get a better accuracy or in a shorter time. That is there. But if you want to do apply deep learning, the one point you should very careful about is you need a surplus of data. If you have huge data with you, then go with the deep learning. Otherwise, it will overfit with the data. If the intelligence will, it's whatever the results you are getting is not so appropriate. So this diagram may give you some more clear idea about when we go with the deep learning. So if you have a small data, go with only with the statistical modeling. If it's little high, go with the machine learning. And if you have a plenty of data, surplus of data, go with deep learning. Okay. When we go with the deep learning, we should understand this as two things. It has two things. One is we should understand deep learning with the structure wise. Another one is learning wise. So what is structure wise is we should understand about what is input, what is neuron, what is the activation function, and what is the functionality of it, what is the layer, where what is the weight and how to set the weight and how to update the weight and all those stuff, and what is the output. So these things we should know. Okay. So now I will take you to that structure wise. What is that? Then we will go with what is how to understand the deep learning in a learning wise. The first point what we have to understand is input. But before that, deep learning is new. If I ask this question to you, some of you may say yes, some of you say no, but definitely the deep learning is not so new. Okay, it's a very old one. It's the concept started with the perceptron algorithm in 1948, but on the time it's very difficult for them to use this kind of deep learning as the requirement of heavy computation is not there and requirement of data is also not there. I mean, they have data, but they don't have an environment to store the data. But now we have very good environment to store the data as well as computationally heavy machines are available with us. So now we can go with deep learning. Okay. Now we want to design a system. Say, for example, I want to consider the same example, whether a particular student is pass or fail. That is my problem statement. To understand whether the particular student is pass or fail, we want to feed three inputs. One is age, number of hours of study, and average previous test score. These three we want to feed it into that system. And then the system should try to learn from the data and say it should say whether the particular student is pass or fail. Okay, for that we want to have three inputs and we want to design with some number of nodes and layers. And finally, we want to design an output with the probability. Okay, right. Now, from here, I will let you know about what is the structure of a deep learning. So how to design a structure? If there is a problem, how will you structure it, or how will you design the problem to fit into that, or how will you design a deep learning network first? Then only you should understand how to do the training and other stuff, right? So the first point when you consider any problem, the thing is what is the input? So according to this case, what is the input for me? What is the problem statement we have? Whether the particular student is pass or fail. Okay, based on what? Three inputs: age, hours of study, and average previous test score. So these three things: age, average test score, number of hours of study. These three I want to feed as the input. So that I can consider that is the input for my deep learning algorithm. Now, how to feed that input to the system? In general, the system, even the deep learning framework, can understand only the format called tensors. Always we want to feed the data as tensors. If you heard the word tensors, don't get tension. It's nothing else other than our matrix. In a computer science world, it is nothing but n-dimensional matrix. So what we want to do is we want to convert, or we want to feed any data in terms of matrix. So if we have a image, say do something, or understand that image as matrix and feed it to the system. If you have audio clips, understand and do something to convert the data into a matrix format. Okay, it's a n-dimensional matrix. So for example, if I consider a table, structure data in terms of rows and columns, if I consider a table, it's a two-dimensional tensor. Each column will represent one. Each column is we have a columns, right? Columns and rows that we can each column I can consider as a one tensor, and we can feed it into the system. Okay. The other point we should understand is this DL generally will not understand the categorical data. It will understand only the numerical data. So to make our data as a numerical data, or to represent your data as a numerical data, always we should go with one-hot encoding. So what is one-hot encoding is you can represent any categorical data as some numbers. So for example, if I say it's a gender, we can understand there are two genders, male and female. You can represent female as 0 and male as 1. So always, or vice versa is always possible. So by seeing the 0 in the particular value, we can understand that as it represents female. Okay, so it's one-hot encoding, right? Now you are talking about, you may ask me, sir, you are talking about input in terms of features or input in terms of structured data. That's fine. But now if I say image, how should I feed it? The image can be fed to the system as again it's the multidimensional tensor. As we know, we have pixels values. Rows and columns represent the pixel values. That will become a two-dimensional data, right? Then third, we will represent whether it's a color image or in color, what are the color combinations for RGB. So that we have to represent, that will be in another dimension. So two-dimensional data, it's all the pixel values. All the pixel values we can represent as a two-dimensional, and the third dimension RGB color can be represented in a third dimension. So now what is the thing? I'm dealing with the unstructured data as image is unstructured data, and we are feeding that image as pixel values and RGB color. So now we can consider this as a matrix. We can consider this a three-dimensional matrix. Two dimension is used for pixel values and third dimension is used for RGB color. Now, if I have 100 images, in that case, what will happen? It will become four-dimensional data as, say, for example, 100 images of 512 cross 512, then 512 cross 512 will become a two-dimensional data. And to represent RGB, we need another dimension, which is we can represent as the other dimension. Then the images, for each images, I need this. So 100 different different images are, as I have 100 different images, I can represent this as four-dimensional tensor as 512 cross 512 cross 3 cross 100. Is there any doubt till now? Is it good? Is it okay?
Is it okay, Professor? Go ahead.
Yes,
Okay.
sir.
Yeah. So now we are able to understand what is the input. The next point we should understand is how to design number of layers. The second point is number of layers, and along with layer, we should design number of nodes in each layer. That we have to do that. So for that, if I take a keras, we have a very simple structure can be used, or it's a very simply we can design this number of nodes and number of layers in that. So for that, we have to use one parameter called input shape. So here the input shape is nothing but it starts with representing our input data. So as we say, till now in our example, we saw that three inputs. Okay, age, hours of study, and previous test score. That we have to feed that as the input. That's the one parameter. After feeding the input, I have to design number of layers and number of nodes. So these two things now we have to see. Okay, so now we have to understand that as we need to fix number of nodes for inputs. That is also one of the things, right? Always it's a first layer. There is no need of understanding the different layers here, but at least its input should be in a first layer. And if you say first layer, how many nodes should be designed? That we have to understand. For example, I'm go back to this. So now we have to understand that as we have to design the input, then number of layers and number of nodes in that. That's a different issue. But first we want to start with the number of, input. If you start with the input, we should understand how many nodes should be there in the input. Got it? So we can design it by using a simple thing as we can say input dimension is 10. For example, if I mention input dimension as 10, meaning here is we will feed 10 input into this system. So we will say we will feed 10 input to the system. But rather than that, in our example, what is the input? How many inputs? Three. So what we have to say here, input dimension is 3. That's it. So in this way, we will be able to define this. The second one is, I said that now we are able to design the input. The next component is we have to design the next layer with number of nodes. The number of nodes needs to be decided. That's a different issue. But now I have to say I want to design it with 5 nodes. Okay. So to say that, here we will say we want to add 5. The meaning of this 5 says I want to add 5 nodes. Okay, I want to add 5 nodes in the next sequential model or next to this input. I want to add 5 nodes. I think someone muted me also. Okay. From where you are unable to get it? Okay, I will repeat from input shape. So here we will start with model. To design the model, we are saying like it's a sequential model, meaning that we will add number of layers in a sequential manner. That is next to next, we will add it. Then first we should start with input dimension. Here we are mentioning like it's a input dimension is 10 means the number of inputs should be 10 in the input layer. But here, according to our example, we want to have only 3 inputs. So we want to say 3 inputs. OK, the next one is we want to add 5 nodes. We want to add 5 nodes in the next layer. OK, the next immediate layer, we want to add 5 nodes. And here we are mentioning like it's a dense. Meaning of dense is the particular node should be connected to all the previous nodes. I mean, all the nodes of previous layer. The same way, it should be also connected to all the nodes in the previous layer. So in this way, we will design this network. Other than that, we are mentioning like the activation function is sigmoid. That is here, there is an activation function. We will see what is activation function in the coming slide, and we could understand it. Okay. Then again, what we are doing here is we want to add model that add dense of 1. And so meaning is we will add one node in the next layer. And as we don't have anything, we can consider this as the final output layer. Okay, again, we are saying like it's a dense. So the particular node will be connected to all the previous nodes completely, fully connected. Then in general, we will go with the normalize and we will standardize the data. So generally, when we go with the deep learning and machine learning algorithms, we will normalize the data for better norm. Hello, sir. Please mute all of you. Yes. I think Divya ma'am, your way is right. Fine.
Sorry, sir.
Your way is right, I think.
Okay, sir.
Yeah, maybe in the last I can discuss with you. Yeah, fine.
I'll unmute so that you can answer everybody.
నీకు ఎంత అన్నమాట
Yeah, fine. Am I audible at least now?
Perfect now.
Yeah. So here, the next component we should understand is neurons. So neuron is nothing but it's a always there will be a computation will happen in the neuron. So here it will the neurons will receive the inputs from the previous layer and it will do some computation. Okay, so it's when it do some computation, it will get some output. If that output is actually high enough or it crosses some threshold, it will react. Otherwise, there is no reaction from that particular node. To do this, we have to understand as we will pass some inputs. Say these are the inputs in terms of x1, x2, x3, and xn-1 and xn talks about the features. According to our case, it's x1, x2, x3. The three features, we will pass three features, so that will be the input, and each input will associate with some weight. Right. So this weight should be computed in a way that it should the formula of W transpose X. That's the meaning is the X1 will be multiplied by W1, and each associated weight will be multiplied, and bias will be added, and we will get some output. If this output is greater than some of the threshold, it will react. Otherwise, it won't. And other than that, we will use we will call this as a f of Z. Here the f is nothing but our activation function. In the last slide, I showed you sigmoidal activation function. The same way we can have a lot of activation function. Based on that property, the output will be thrown away. Right. So what is that activation function is? It will mimic the activate or deactivate the function. According to that input, it will do the multiplication and the stuff W transpose will happen, and you will get some output. And that output will be applied or thrown over to that activation function. If that output is greater than some threshold, it will react. Otherwise, no output. In general, we have two different types of activations. One is if you don't use any activation function, then the output is always continuous value. And generally, we may use some activation function. Non-linear activation, we will use always non-linear activation function as the parameter. Sometimes we may use linear activation function, but if you use linear activation function, you can't go for back propagation. Okay. For example, if you use a sigmoidal activation function, the formula given is 1 by 1 plus e power minus z. If you say whatever the input, say z value is 0. If I get 0, z value is 0, I will get the probability of 0.5. And if it's a z value is 2, then I will get something about 0.6, 0.7 as the probability value. So something like the output from sigmoidal output is whatever the value we feed as the input, the output is where ranges from 0 to 1. In here, the 0 to 1 represents the probability. So the probability is 0 to 1. Okay, of the sigmoidal function. Something like that. ReLU is the other activation function, and now we could understand this structure wise. So we understood about the input, how to design a number of nodes and number of layers, and what is the activation function, what is neuron, how the computation will happen. All these things we could understand. Now the last point with respect to model or designing the neural network is model. The model is the one keyword we have to use it to understand or to build the sequential model. Say we will start with the input, design the neurons in intermediate layers, and output we will make that is a stack of layers. Okay. So for example, if you consider a simple sequential model, we can import Keras sequential model as well as the dense and activation function we could import. Then we will start with the sequential, and here we are saying like dense of 10 and input dimension is 15. Meaning of this is we will start with the 15 nodes as the input. So our input dimension is 15. We will go with the 15, and we will start with the next node will be about 10 nodes will be there in the next layer. Then we are making that as a ReLU is the activation function used here, something like this. Okay, you can add any number of layers by just giving this model.add dense of 5 and the previous, what is the name of the previous this line that you can give it, right? So the other point we should understand is dense layer. Dense layer means that the particular node will be connected to all the previous node of the previous layer. It will connect to all the nodes in the previous layer. Okay, then we can call that as a dense layer or fully connected. We can call otherwise we can call that as a fully connected. And other than that, we can have some dropout layer where we may remove some of the links. Some weights can be removed so that our system will perform better. That is, overfitting may not happen here. Okay, you could understand about all the other layers by seeing this embedded layer, convolutional pooling layer, and all those things. So now you could understand the layers also. Okay, so now we understood about the structure wise. The hereafter I will take you to that learning wise. as I already said, the DL should be we want to understand in a two ways. One is structure wise, another one is learning wise. Okay, structure wise is over. Now we will go with the learning wise. So what is learning? Learning is nothing but we feed some input.
Excuse me, sir.
Yeah.
Sir, can you repeat the concept of input dimension? Actually, I've got confused. Input dimension in our case, it will be 3 because we are taking 3 parameters.
Yeah. Another
Okay, so
example here, I'm saying like 15 as the 15 inputs.
okay, so in this code we are taking 15, but the example we have taken previously, in that case it will be 3. Input dimension will be 3.
Yeah, that is 3 only. But just
Okay,
for
sir.
another example, just for one
And
example.
10, and dense 10 means 10 is in the next layer.
Next layer, and then switch, all the nodes will be connected.
Yes.
In the
Okay, sir.
previous.
Thank you so much, sir. Thank you.
The next one is learning. So we feed some input, we will get some output. If the output is correct, that is, it's a learning phase. We should know the input as well as the output, and we will get the same output. If if the system is gives us the same output, the meaning is the weight is okay. Okay. How to say that? I have to show this. Don't have a diagram. Okay. Now assume like I have a data set with the age 30, number of hours of study is about 12 or whatever it is, and average previous test score is 90, something like this, and I'm getting that as the probability of pass or fail. Okay. Now okay. Now in this case, I know the output. For example, the age 30, number of hours of study is 15, and average test score is 90. I know the result as the probability of that guy is pass. And that output also I am getting as pass. Is it okay? It should be okay. If I am getting the wrong output, the system says like the student is fail. But the original data, I know that the student, for these things, the student is pass. The output should be pass. But the system says wrongly says that the probability is fail. I mean, probability of his thing is fail. Why I'm getting this output as fail is, I said that there is a associated weight with each links. As this weights are not proper, as we will start with the random weights, then the weight should be appropriately tuned to the input and output. This we call as the learning. That output, as we are not getting the proper output, meaning is all the weights are not appropriate. So what we have to do, we have to update the weight. How to update the weight is, we have to get the some error. This error, based on this error, we have to update the weight from backwards. Forwardwards, we will get the output, and backwardwards, we will have to update the weight. Say, if you want to update some weight over here, this will affect by all the weights. And as it's all affects all the weights, it should affect with all the other weights also. So this way, we have to update the weights in a backwards. We call this as a back propagation. Okay, so we have to update the weight in a backward manner from output layer to input layer. We call this as a back propagation. To better understanding, I can give you one example. So for example, even more and above, we have to understand the minute update should also happen with respect to probability also, certainty also. So for example, even I'm getting like a particular student as pass. The input, what I know that the output should be pass. The system is also giving me the pass as the output, but the system says the 87% of probability. But what I'm expecting is, for the particular transaction, the system should say 100% probability. Even my system is able to give only 87%, meaning here is the system is having about 0.13 of error. This error needs to be updated. How to update the weight? I have to update the weight from output layer to input layer. We call this as back propagation. So the objective wise, what should I say here is, we need to reduce the loss. Got it? The other loss functions are mean squared error or mean absolute error. These are the other loss function we could use it in our system to understand how much the error is. And based on this error, we could update the weight and your system will it will perform better. We call this as a supervised. Why we call this as a generally supervised learning is always we know the output, and based on the output we could fine tune or you can update the weight properly. We may call this as a supervised learning, right? And other loss functions are here is binary. If the output is actually a binary class, we can go with the binary cross entropy, or if it's a class label, say more than two possibles are there, then we can go with categorical cross entropy. So we can say like type 1, type 2, type 3, type any number, and the last can be given as yi log to yi, and the summation of 1 to n. It's nothing but number of class labels. So that many errors will be available. So all these error we could add, and we should see whether that error is 0. If error is more than that, it's a meaning that our system is not performing well. We have to update the weight, right? So you are saying, like, you may ask the question, say, sir, you started with the random weight. Yes, always if you start with the random, always there will be a error and you want to update the weight. But how to update the weight? Is there any way to update the weight? Yes, there is some way to update the weight. We can't randomly update the weight, but there is a way called the one way we have to use optimizer. Okay, the optimizer will take, it should understand that as how many iteration is required and how to reduce the weight, whether that my weight is updated properly to reduce my loss function. That should be ensured by a optimization function. One of the optimization function is backpropagation. And here we will use derivatives, partial derivatives, and chain rule in a calculus. So here as you understand that partial derivative is if change, what is the change with respect to other parameter? Okay, all these things we have to understand, and then optimizer will take care of it. It will try to optimize. It will optimally. It will update the weight. In other way, we have a stochastic gradient descent. Will update the weight for each transaction wise. It's other way. Or gradient descent is the another optimizer. We can update the weight for some group of transactions. Say even as a whole input transaction, we could update the weight. That we can call that as a gradient descent. Or if you want to update the weight for each transaction, you can go with stochastic gradient descent. And Adam optimizer or other optimizers are available. You could see and understand how those optimizers are works. Right. Now we decide the network, we feed the input, and we got some output, and we understood that the output is not proper in initial stages. So we asked the system to update the weight by using a backpropagation algorithm or optimizer. Then now the system is able to understand, and then after some time after some iterations of some epochs, the system is proper. Okay. Now we have to ensure whether the system is worth enough to go with real time. For that, what we have to do is we have to feed some training data. That till now we used only the training data to understand or to make the system train, or to make the system supervised learn by supervised manner. All these things. Now we will go with test data. In our system, we think that the system is learned better. Now we go with test data and feed the test data and understand how much is the output. We can go with the different metrics, say like binary accuracy or categorical accuracy or sparse category accuracy. This metrics I am talking completely with respect to testing data. Till now we are not feed any testing data. We fed only the training data, and for the training data we try to learn from the training data itself, and we tuned based on the training data itself. Yeah, the loss function and all the other things we did only with the training data. Now we will feed the test data and see how our system is performing. If it's not perform well, again you have to go back with the training phase and do that. If its model is working better for your testing data, then go for real time. Okay. So with all these things, we have a very simple command called compile to make the model as well as all these parameters set in a keras. And by using this, we could do very simple. We could design a simple deep learning network very easily. Okay. So here another example. It's not related to our age. I mean that example here. Just another example for you to understand very clearly. Input dimension is we are setting up 10 inputs. and the next layer 32, and next to next layer will be 16, and one more layer with the one. So mean mostly it's the output layer, and here we are using Adam as the optimizer, and the loss function is binary cross entropy. So this loss function is for training data. It will use this to understand how good the training is, and this matrix is used for test data, how good your system is able to predict for your test data. Okay, right. Now this is with respect to our condition, our data set. Before you go, we have to understand about validation data set. It's other data set, which is we can divide the data set into 60, 20, 20. 60% for training, 20% for testing, and 20% for validation. In that case, I want to generate some data, say some transaction 6,000 transaction with the 2 class labels. Okay. Now we are designing our some network. We are designing like input dimension is 10. All these things, right? So we are using RDM optimizer and binary cross entropy and all that stuff, and we are executing it for epoch batch size of 64 and epoch of 3, and we are feeding the validation data set, and we see how our system works. Is it easy now? Any challenge, any doubt on this? Any doubt? Okay, I'm not able to see that. Okay, fine.
So like I muted them, so people can use their reactions to tell the reply.
Okay, I could not see that. That's fine. I may move with the next topic, and then finally
It's
we
okay,
can.
sir.
Yeah.
It's clear.
So the next, we should understand about how this deep learning can be used in network intrusion detection system, how to design an NIDS system or NIP, even NIPS system is also possible here. But at least here I want to spend little time on how to design a network intrusion detection. What is it, and then why we need deep learning for it. So now we have a huge amount of data is every day we are generating, and then we are using network and all those things. If you use a network, always intrusion is possible. So the objective here is to find the intrusion. So to find the intrusion, we call this, we can design a system which that system is known as intrusion detection system. Okay, a lot of intrusion is happening in each and every day. It's very difficult for us to design a system always. It's a very complex. We need to design a very complex system. So here we want to have a support of deep learning to get to design a deep network intrusion detection system. Right. So if you take a network traffic, we can divide that into 2 things. One is normal traffic and malicious traffic. And our objective is to identify a malicious traffic so that we want it should avoid, it will help us to avoid the challenges as the intruders get something out of our system and all those things. Okay, so we want to detect it. So we want to understand and detect an unauthorized access to the system. We call that as a intrusion detections. So here we can do it in 2 ways. It's something like our antivirus system we can do as the host-based system. So in a host-based system, we have to install some software in each host. Each system should have it. Another one is network intrusion detection system. Now our objective is generally we want to move only with the network intrusion detection system, where the particular system will be implemented in a network as the whole campus wise or some huge network may be available. In that we could understand, we could install this kind of software or hardware sometimes to detect network intrusions. Okay, so we are focusing on network intrusion detection system here. Why NIDS is the very big problem here is the voluminous of data is huge. Actually NIDS is a big data problem. Volume of the data is very huge. and accuracy is actually not so good with the existing systems. It's a lot of human interference is human involvement is required to identify the network intrusions. And when we take up with respect to the data, cost wise is very high, financial and computationally, the huge environment is required. And now we have diversity. That's meaning here is numerous number of network protocols are available right now. Mobile network, in mobile we have different types, and we have different formats, 4G, 5G, all these things. Everything put together, it makes diversity. So identifying the proper network from this diverse data is very difficult. Another one is dynamics. Each and every day, their modern networks makes us very dynamic. Different networks are coming up, network protocols are coming up. It's very difficult for us to design a network with the existing data. Okay, right. All these things will comes to on one point here is low frequency attacks. When we go with network intrusion detection system, fraud detection system, and these kind of systems, there is a huge challenges, low frequency attacks. Meaning is you will get very few transactions of fraud or these kind of intrusion in a very minimal transaction when compared with the normal traffic. Say, for example, if you have about 1 day of time, normal traffic will be about all the time you will get only normal traffic, and only 1 second you may get only one out of about 1 lakh of transaction, only one transaction may be a malware or one transaction may be a intruder. It's very difficult for us to understand that. We call that problem as class imbalance problem. Okay, dealing with class imbalance is very difficult in machine learning and deep learning algorithms, as generally your machine learning and deep learning algorithm will work better for majorly occurred class. So we have to understand how to design a system to deal with imbalanced class. Okay, it's a very important challenge. So many researchers are working right away. And adaptability, you could design it for something, but the system should work for all the other environment on the fly. How good your system is, that's another very big challenge. In a nutshell, accuracy in the actual environment is very less. When we take up if you design a model, high false alarm rate will be always will be there. We have to deal with that. Class imbalance, as I already said, class imbalance is a very big challenge when we design an NIDS. And all these things will have a lot of challenge. The data and detection rate, accuracy, and all those stuff, everything put together, it makes us the real-time challenges. How to deal with that? It's a very big question mark, right? As we already have a machine learning techniques, now we are incorporating machine learning techniques and it is working well, but it is not good enough. Why it is not good enough is the machine learning algorithm is not able to deal with volume amounts of data. In-depth monitoring is not possible with machine learning algorithms, and different protocols makes the problem to the machine learning algorithms. And other than that, the majorly a human intervention or interaction is highly required when we design with the deep learning model. In the machine learning model. Okay, so to overcome all these things, we want to go with a deep learning model. So we want to make use of this deep learning model by developing a practical models. Okay, when we go with the deep learning models, we have generative models, discriminative models, as well as hybrid models. So we can take up any of this, and we could design our better network. So in a generative models, generative model is otherwise known as unsupervised learning. We can, as we have a class imbalance problem, generally we could design this algorithms as unsupervised by removing the class label. If you remove the class label, then all the other data will become a unsupervised data, as we don't have any class label. Okay, so on that time we could design a better generative architecture, better generative model. Then we could use that for our future purpose. For example, autoencoder can be used. So we could feed all the input without class label, and here we will compress the data. We call this a latent factors, and by using this we could reconstruct the output. If both are input and output is same, it's meaning that the in between layer learned it better, correct? So this will reduce the complexity of the algorithm, as well as computation time is very less. as we are removing the class label, it will deal with the class imbalance problem also. So that way we can use autoencoders. The other algorithms, say like a restricted RBM or deep belief network, all these algorithms can be used here. Even nowadays, as these attacks are associated with the time as the another parameter, we actually, as a researcher, we want to design neural network with time parameter. So we can use recurrent neural network or LSTM or GRU kind of new architectures, which is dealing with sequential data, sequence of data, as well as sequential data is the other way. We can use that also in this problem statement. Another architecture is supervised learning architecture or discriminative architecture. Generally, we may use a convolution neural network or any other supervised learning network to adapt to this environment, and we could use it. But as I already said, always if you go with the supervised, this class imbalance is the major challenge. And when we go with the unsupervised learning, the learning is not so good. Okay, to overcome this, nowadays we are coming up with the hybrid architecture. It's nothing but combination of generative and discriminative models. So in that, what we do is we will take some real-time data. Here, it's a real-time images is just a representation. You could take a real-time data and from some samples you can get it. And here you could apply unsupervised way. You can feed only the latent factors, and that will generate some data. And these two data will be compared. Okay, the original data and then generated data will be compared, and from that it can understand whether the generated data is real or fake. So in this way, this way also we could design a network intrusion detection system. We can feed the real network here, and here we can form a unsupervised learning method to get a better generator. And these two will be we will be comparing the original data with the generated data, and if both are same, we can understand whether the real data or otherwise fake data. From this, we could understand a better model can be designed, and this can be used in a real time. Okay, that's all about my session. If you have any doubt or any clarification, you can ask. You may make use of this time. Thank you.
Yes, sir. Sir, I'll unmute the participants now. So if they have any queries, they can ask.
Yeah.
Yeah, so you're all unmuted. Please feel free to ask any queries if you have.
So very impressive session.
Thank you.
Dr. Mohammad Parvez here.
Thank you, sir. Do you have any question?
No, sir.
Yeah, thank you.
Any queries from participants? Okay, I think the session was really so clear, and so participants don't have any questions. Okay, Punita.
Hello, sir.
Yeah.
Hello,
Yeah,
sir.
please go ahead. Please go ahead.
Yeah, good morning, sir. So just now you explained regarding class imbalance issue, class imbalance problem.
Yes. Yeah.
So these DL models are only suitable for image classification or text classification.
Image, text, word, even unstructured data, structured data, all. Anything is possible, sir. But the thing is, how you are feeding the data. How you have to think as tensors. How to feed the data as tensors, so that your unstructured data can also be fed into this system.
Okay, sir. Thank you.
Punita Ponmalar, I think you wanted to ask some question.